Hi, virtual NACIS viewers. My name is Joe Milbrath, and I'm a cartographer at the National Park Service at Harpers Ferry Center in West Virginia. So today I'll be talking about the world of 3D maps. And some of you have probably already stumbled down this deep, dark rabbit hole of 3D mapping. But for those of you who might be curious or haven't really explored this area yet, I hope these slides can give you some light on how fun it is to really make these maps. So 3D maps, oblique views, panoramas, I'll use these terms interchangeably, they can take on a variety of appearances and functionality, like this beautiful panorama of Katmai National Park and Preserve made by Tom Patterson, or this map of Exit Glacier that illustrates to map readers that they have a long slog up to the Harding ice field. It can also be used for thematic diagrams like this geologic illustration of Crater Lake National Park. And they can bring life to a small historical park like this map of Booker T. Washington National Monument that's made by my esteemed colleague, Jim Maynard. So these maps are incredible tools that can be useful to connect visitors to a place that they might not be able to access. Here at Katmai National Park and Preserve, most of the visitors flock to the Brooks Camp and then nearby falls to view bears eating salmon, but few actually experience the remote stretches of this sprawling park. And an oblique view can kind of help give them a bird's eye view of just this wild place that's seemingly out their doorstep. So these maps and diagrams are incredibly useful, but how do you go about making one? Well, first you need to determine whether your project warrants making a 3D map. There are a handful of items that you need to consider before embarking on this journey. And I've gleaned a few points here from a very detailed tutorial put together by Tom Patterson that can be found at his website, shadedrelief.com. And let's just go through a few of these. So first, producing a 3D map takes a lot longer than a standard map. There are seemingly endless variables to consider when experimenting to come up with a desired outcome. You'll first need to create a georeference base map before venturing into a 3D version. And here on this map of Whitman Mission National Historic Site, I have all my vector layers ready that I'll need to then overlay into a 3D software of your choosing. So this is the later 3D scene or 3D rendering that I've put together using Natural Scene Designer, some Photoshop work, and Illustrator. And with all that extra time and experimenting, of course, the costs go up, sometimes exponentially. So beware of that. Data. So 3D mapping is not possible without essential data, including digital elevation models and aerial imagery. A high resolution DEM might be required to make that large scale scene that your client needs. And sometimes a critical satellite image is full of clouds or smoke, although I'm told Earth Engine can take care of some of that stuff. Or the high resolution nape image that you need is completely snowed over. So another important item to kind of look into is international boundaries can sometimes hinder 3D mapping efforts. Here on this render of Glacier Waterton International Peace Park, not surprisingly, the national land cover data set ends at the Canadian border. So another data set will be needed to cover Waterton and then the surrounding Canadian Rockies. 3D maps can also require vast data coverages beyond the area you want to highlight. So especially if you're looking to include a horizon or sky, beware of this. While focusing on Katmai National Park, it fills 2/3 of the map, the foreground and midground, but that 1/3 area of background that's needed covers nearly 400 miles into the distance. So that's a lot of extra data that you'll need to process, in which can prolong rendering times as well. So some terrain is not entirely suited for 3D mapping. Alaska's terrain happens to be optimal due to its expansive and unpopulated landscapes, like this image here of Kenai Fjords National Park. But some terrain is also too complex and important features can remain hidden regardless of the viewing direction. So just be careful of that. georeferencing, once your data is rendered in the 3D map, it loses all georeferencing. At Harpers Ferry Center, all of our planimetric maps are geospatially aware and available for download at the Avenza Map Store. Hint, hint. But if your client wants your map to be used for navigational purposes on a mobile device, a 3D view probably isn't the best option. And yes, I still have an iPhone that looks actually just like this one. And our last limitation is foreshortening. So due to the oblique viewing angle of a 3D map, the vertical extent of the map is then shortened. So this effect can cram a lot of important information into a relatively small portion of the map. Elements in the background typically have less emphasis than items in the foreground. So in this example of Dinosaur National Park from the mid-90s, you can see the majority of the foreground is non-park land. The midground is squeezed into a really small area, and then the major rivers, the Yampa and the Green, are obscured by the steep terrain. And then in the background, you have these beautiful snow-covered peaks and a nice sky with wispy clouds, but those actually don't really help the visitor orient or navigate throughout this park. So to correct this, in 2015, Tom Patterson rendered out this planimetric oblique version, which corrected both the issue of foreshortening and widened the view, and then also fixed the occluded rivers of the Yampa and the Green. So once you've gone through all those and you decided that you want to create a 3D map and go down this rabbit hole, you'll need to set up the scene. And this early phase of the project is the most vital and will have a huge impact on how your map will eventually look. But the direction of view, camera height, pitch, vertical exaggeration, light angle, sky or no sky, the options within one of these maps is completely limitless. So at this point in the game, I'll typically start a search for the best available data, and then I'll overlay the most important items and whether they're roads or trails or the park boundary onto a digital elevation model in Natural Scene Designer to see if any of these areas are occluded. Here you can see I have all those elements on there to show that thankfully nothing really is disappearing behind any ridges or falling off the map anywhere that I really need to show. I'll then render a handful of scenes from different angles for the client to analyze, and then we'll eventually select a scene. It's really important to settle on a view at this stage because any small tweaks, say to the direction of view or something later later on in the mapping stages, basically results in starting all over. So lighting, this is also a really profound portion and can affect the feel of your map. Light direction and elevation of the light angle can make your map either look really bright or really dark. This north-oriented view of Glacier National Park shows the effects of various light directions. And you can see light coming on a north-oriented view like this one, you can see light coming in from the southwest or the southeast are optimal. If your map view is facing a different direction, you'll probably need to experiment with other light sources. So I'll use the remaining portion of my talk just to go through the development of a 3D map, one that I recently made of Cedar Breaks National Monument. And this is the previous map that was kind of in circulation for quite a while, and it felt a little utilitarian. And while it fit the National Park Service's visual identity, I didn't feel that it captured this. And so after running through my checklist of reasons not to make a map, I thought I'd give it a shot. And went and gathered all the data, set up a few scenes, got approval from the park to move forward, and then was able to cobble together a pretty nice 3D view of the park, which I'm pretty happy with. And so now I'll kind of give a brief walkthrough of how I got there. So using Natural Scene Designer or your trusty 3D mapping software at home, I rendered out 4 layers built to build my map from. So I have a shaded relief layer, terrain texture shader, a nape image overlaid on the DEM, and then a tree map that was made in NSD. I also used a height mask and slope mask, but you can get by without them. They're also fairly easy to render in NSD. So here's the finished relief art with all of my layers listed on the side, and I'll start from the bottom and build up from there. So I always start with a rendered shaded relief. Here I have a 1 meter LiDAR mosaicked on top of a 10 meter NED DEM. And the 1 meter is kind of pivotal to really tease out some of these nice details in the cedar breaks area. But then on the peripheries, you can kind of tell that the DEM gets a little fuzzy, and that's the 10 meter, but that's all right. So for this project, I've actually only used the shaded relief to isolate the highlights and shadows, a technique also well documented on shadedrelief.com. I'm really plugging you, Tom. And here I have separated 2 separate layers of shadows and highlights, one rendered from the high resolution shaded relief, and the second from a downsampled 30 meter shaded relief. And the first shows the details of all those hoodoos in the breaks area, and kind of gives a lot of good texturing that I want to see. And then the second 30 meter downsampled illumination layers give these really nice kind of broad brush strokes that will kind of calm the rest of the image. So to start, I actually start with just a blank canvas of 10% grade filled background. So it's just completely blank, and then overlay this terrain texture shading layer on top of that, set to just normal blending mode and 75% opacity. And it already kind of looks nice. I like it. Then on top of that, I'll add that rendered nape image, and then I actually have a second nape image that has a little bit of bump mapping just to add a little bit more texture. I always like to see a little more texture. And then to those layers, I'll add a little bit of, or some adjustment layers to add contrast to the image, lighten the rocky breaks areas, add some saturation to the image as a whole, and then tweak the color of the green forest just so they're a little lighter. And that looks pretty nice. So I added the rendered trees from NSD, that tree map, and just set that to 40% opacity. Gives just another little added hint of texturing to the forest. Otherwise, they can look a little flat if you don't have some of that in there. But on top of that, I also added a little more saturation to the breaks area using another copy of the nape overlay with just the breaks area masked out. So it just kind of brings the color up a little bit and teases out some of that orange. Then after that, this next step, I've actually imported some vector layers from Adobe Illustrator to separate the surrounding Forest Service and wilderness areas and just give a little more definition to the park. And those are both set to just like 35% opacity, and it just kind of gives a little definition there. I also created just a separate layer of touch-ups and used just a little brush tool to create some striations and rock cracks in some of the areas that have those stretched out vertical renders on the vertical surfaces of the DEM. So it just kind of gives a little more character to those slopes. After that, I imported another vector layer of the hydrographic elements to the map, so just the drainages, and brought those in from Illustrator, and then used the effects panel to add a drop shadow, a little bit of embossment, and this effect just kind of sets the drainages into the landscape. And then I also just kind of tweak the color a little bit. All right, and then this is the most fun little addition here, is the lighting. So this step can be added at any time in the process, but this is where I had it in my panel. I have the shadows set pretty low, highlights are a little higher, but adding this illumination just really makes the thing pop, and it gives some nice depth to the complex ridges and valleys of the breaks area. So you can also see it's a little busy around the edges, but thankfully I've just brought in this nice little white non-park fill area that just kind of de-emphasizes everything around the park. Your eye goes immediately to the park boundary and everything within it. And yeah, I think it looks pretty nice. And then I added another white layer on top just to kind of lighten everything to allow the labels to be a little more legible. So when the relief is finished, I placed the artwork back in Illustrator, bringing the vector labels, trails, roads, symbols, And I know that's a really quick run through, but I'm happy to chat anymore with anybody throughout the week if you have any questions. And also, please, if this piqued your interest at all, I highly recommend going to Tom's website and reading his tutorial. It has like 27 chapters and really deep dive on all this stuff. And yeah, I'm always here for questions. So thank you very much. Appreciate it.